Hi everyone. In this video, I will be discussing about data collection and presentation. So before we start, just a disclaimer, I do not own the PowerPoint presentation, so credits to my beautiful fellow mathematics teacher here in ADFC, Miss Annalyn A. Rapada, for the informative PowerPoint presentation. So let's start. So, before we dig deeper regarding this topic, let's discuss first some important terms or important concepts before we proceed with the computation or other uh, parts of data collection and presentation. So, let's define first collection of data that refers to collecting information about something with an objective to analyze it or extract some meaningful information from it. So take note of the following terms: analyze or extract some meaningful information from it. So if we collect certain data, it shouldn't be put to waste. So whenever you collect data or whenever you gather information, it should be utilized for something meaningful. So let's say, for example, if you're interested in someone, of course you will be asking, you will be collecting some information in order for you to better understand that person. Okay. Next, we have data presentation. So after you have collected the data or the information, that will be the time that you will be presenting the data. And data presentation is defined as the process of using various graphical formats to visually represent the relationship between two or more data sets so that an informed decision can be made based on them. So, in presenting data, there are actually a lot of ways. So, later on, we'll be discussing that one. So, here are some examples of activities involving the collection and presentation of data. First one is students collecting data from their localities about the number of people with COVID vaccines. So that's a way of getting information in the community. Second one, a football fan collecting information about the goals scored by his favorite player. So there we can see that a certain fan is gathering information in order for him or her to know the score being obtained by the or his or her favorite football player. Third one is a record company collecting information about album sales by their artists. So that's very important for like businesses, record businesses, so that they will see their sales if they are getting a lot of sales based on the records that they are producing. So those are examples. The examples above, this one. So these are ways of collecting data. Now below the graphs, these are the ways that the data are being presented after gathering. Okay? Next, there are two types of data collection. The first one is what we call as primary. So, primary data is obtained directly from the source of information. Say, for example, you have interviewed someone. So, the information that you have gotten can be considered as primary data because you got the information firsthand from that certain person. Next, we have secondary. So, secondary data, these are obtained or data obtained that have been previously collected by another person or institution for some other purposes taken usually from publications or existing record. So, say for example, you are reading a book or a thesis or a dissertation. So, the information that you have gotten from that certain book that you have read is secondary data because the person who made the book, he or she was the one who gathered the primary data, and you are the secondary gatherer of the information. So that's it for types of data collection. Next, we have methods of data collection. Now, we have different methods. The first one is what we call as the experimental method. So, the data are collected under controlled conditions. In your junior high school, senior high school years, if you had, or I think you had science subjects, and in these subjects, you usually conduct experiments, and there are controlled, or there are certain variables, like say for example, plants. You will be asked to observe a certain plant that is placed outside, like under the shade of the sun, and another plant that is placed like inside the classroom. And those plants will be left for, let's say, how many days or a week. Then after a week, you will see the differences between the both plants. So that's experimental. So next we have observation method. Data collected by recording the behavior at the time of occurrence. So observation method can actually be applied also in, like, in your science subjects. There are certain experiments wherein, like, they put certain or place certain animals in certain conditions, and they will observe how the animals would react under those given circumstances or conditions. Or say for example, in terms of behavior, you can observe a certain person, how he reacts, how he responds if placed or put in this certain condition. Next, we have the survey method. So data are provided by identified respondents, either by personal interviews or mailed questionnaires. I think you are familiar with the PSA. So the PSA, the Philippine Statistics Authority, this is an agency that conducts surveys and gathers information from the entire population here in the Philippines. So the PSA, they were formerly known as the NSO, National Statistics Office. So they changed their name, or the name of their office, to PSA. So they hire people to like go to barangays and visit households to gather information in households, in families, asking for the number of people living in a certain home, their income, their way of living. So that's a survey method. And they usually bring like a piece of paper, a questionnaire. It's either they ask their respondents or the people to answer the questionnaire, or they're the ones who will ask the question and they will just check the questionnaire based on the answers of their respondents. So that's survey method. Actually, even in social media, in Facebook, in YouTube, sometimes I encounter surveys like there are questions that pops up. Have you seen this ad recently? And you will just answer with yes or no. So that's it for survey method. Next, we have the use of existing records. Data are collected from published materials like reports, personal files, historical records. So this is actually very useful. Say for example, you would like to know the increase of population in a certain locality. So you can gather information based on existing records. You can ask for the report of the population for the past years, and you can compare it to the next few years, given that there are already records in the certain locality or the certain municipality. Next, after gathering data, of course, we need to present the data because what's the use of gathering information if it will not be put into use? So there are also other different methods, in data presentation. First one is textual. So presents data in narrative form to describe the data. So from the word itself, text, this method of presentation uses words, phrases, or the data is presented in a paragraph form. Second one is tabular. Presents data in condensed form by arranging them systematically in rows and columns. So to put it simply, tabular presentation means to put the data in a certain table. We're familiar with table, right? A table having rows and columns. Third one is the graphical method. So this is actually catchy. It's good to look at because it presents data in pictorial form, designed and constructed to attract and hold attention of readers. And usually, in presentation of data, in using graphs, some people or other people use vibrant colors in order to attract the eyes of the readers. So here is an example of presenting data with texts. So highlights of the data are mentioned in the textual presentation. Numerical measures that summarize the data such as mean and standard deviation can serve as highlight. So this is an example again of presenting data in textual form. So the main or the highlights are being mentioned, like USA, Brazil, Russia, Germany. The different countries are being highlighted because there are colorful squares beside them. And in terms of font size, the font size are larger, meaning these are the information that are being highlighted. Next, we have presenting data with tables. A statistical table that can be constructed to present data collected is the frequency distribution table, or usually called the FDT. So the frequency distribution table is a tabular arrangement of the data by grouping the values into mutually exclusive classes and showing the number of observations falling in each category. So there are two types of frequency distribution table. The first one is ungrouped frequency distribution. The distinct values are used as categories, classes, and with its corresponding frequency. Useful only for data where the distinct values are few and usually used for qualitative types of data. So for the ungrouped frequency, there is only one category or one class. So for example, for the blood type O, so for example, here table 1 is a frequency distribution table for blood types of 25 patients afflicted with certain diseases. So among the 25 patients, there are 7 patients who are or who have the blood type of O. So next for blood type A, there are 6 patients. For blood type B, there are 7. For blood type AB, there are 5. So we have another example. Table 2 shows the FDT for number of cars owned by a sample of 30 families in a certain residential area. Now, number of cars owned and the number of families So for the first class or the first group, so there are 12 families that do not own a car or who do not own a car. Next row, next row, there are 6 families that own only one car. For the third row, there are 7 families that own 2 cars. Next, there are 3 families that own 3 cars and 2 families that own 4 cars. Next, we have grouped frequency distribution. So if you would compare for grouped frequency distribution, the classes, it represents a certain range, 50 to 54. Whereas for the ungrouped, there is only one class or one category. So for the grouped FDT, this is useful for large data sets. The mutually exclusive classes are in the form intervals. So you see here, the classes forms an interval 50 to 54, 55 to 59, and so on. Whereas for the ungrouped, there is only one class or one category. So, usually used for continuous quantitative types of data. So, earlier, as I've mentioned, for ungrouped, it is used for qualitative types of data, whereas for grouped frequency distribution, this is used for quantitative types of data. So, table 3 is an example of an FDT of the distance traveled in kilometers by or from warehouse by 25 delivery trucks of a certain company. So, looking at the first row, this one, the first row. So, there are 3 trucks that were able to travel 50 to 54 kilometers. This one. For the second row, there are 7 trucks that were able to travel 55 to 59 kilometers. For the third row, there are 9 trucks that were able to travel 60 to 64 kilometers, and so on. So, there are actually steps in creating a frequency distribution table. So, let me just give or explain the steps. But I will be creating another video in order to better explain on how to create the frequency distribution table. So, step number 1 is, Step number 1 is determine the range denoted by R. So, range is equal to the highest observed value minus lowest observed value. So, if you are given a data set, you will simply subtract the highest data minus the lowest data or the lowest value. Next, determine the number of classes denoted by K. This is actually a typographical error. That should be K is equal to the square root of N. So where N is the number of observations or cases in the data set. Note the value should be rounded off to the nearest whole number. So in order to get the number of classes, you simply look for the square root of N. So for example, if there are 40 number of cases or 40 values or data obtained, you will just look for the square root, and take note that you should round off to the nearest whole number. The answer should be a whole number. Number 3, calculate the class size or class width. It is the difference between 2 consecutive lower or upper limits, or the difference between the lower and the upper true class boundaries. So here, if we go back, so for example, in this certain class, 50 to 54. 50 here is the lower limit, 54 is the upper limit. So in order to determine the class size, we use the formula C. Class size is lowercase c is equal to R, and we know that R is our range, which I have read and discussed earlier, and K is our class size. So we simply divide both values in order to get the in order to get the class size. The value of C should be rounded off to the nearest number that has the same number of decimal places as the raw data. Number 4, enumerate the classes or categories as follows. The lowest class must include the smallest observed value. So once you're able to determine the number of classes and the class size, you need to arrange the data in rows, and take note that the lowest class, the very first class, should include the smallest value based on the data gathered. Number 5, after defining the class, tally the observations to determine the class frequencies. So I will show you an example later. So once you are able to put the classes in the table, next is you will determine the frequency, like how many occurrences. For example, earlier, so like let's say here in this certain class 50 to 54, the frequency is 3. So for how many times does that certain value occur? So these are additional columns. Again, I will create another video to better explain on how you can create a frequency distribution table. But nevertheless, number 6 is build additional columns to obtain other information about the distributional characteristics of data. So these are the class boundary, class mark or midpoint, relative frequency, relative percentage, and cumulative frequency. And for cumulative frequency, there is the less than CF and the greater than CF. So we have an example here. Consider the scores of 40 students in the final exam in an elementary statistics course. So take note, there are 40 students, and these are the scores that they have obtained in their final exam. So the very first step is to determine the range. Again, how do we get the range? Simply subtract the highest value by the lowest value. So the highest value or score is 112. Wait. So that's 112 subtracted by the lowest value, 44. So if you would be asking where did we get the information, or where did we get 112 and 44, just simply look at the given data above. Okay, so this is the highest, 112. The lowest score is here, so that's 44. Next is to determine the number of classes. So for the number of classes, that is simply K is equal to the square root of N. Now N is the total number of population based on the data gathered. Now here in the example, the information gathered is from 40 students. So that's why we have K is equal to the square root of 40. And as per the rule, you need to round off to the nearest whole number. So square root of 40 is 6.324 and so on. So if you round it to the nearest whole number, that is simply 6. And after getting the number of classes, we need to determine the class size, the certain interval in a certain class. So the formula was C is equal to R over K. So the range is 68. Number of classes is 6. So simply divide 68 divided by 6. We have 11.333. So if you round that off, that is simply 11. So this is an example. This one, the whole table, that's an example of a frequency distribution table. That is how the table will look like after you have gathered all the necessary information. Again, I will create another video in order to better explain on how you can create a frequency distribution table. So, third one or third part is presenting data with graphs. So, after you have gathered information, I told you earlier that you can present information through textual method, tabular method, and lastly we have presenting it with graphs. So data collected can also be presented using graphs. Common graphs constructed are line, bar, and pie charts, and I'm very sure that you are familiar with all of these type of graphs. So qualities of a good graph: it should be accurate, simple, and clear. Accurate, it should not be deceptive, distorted, or misleading. It shouldn't give false or wrong information. It should be simple, should be straightforward, not loaded with irrelevant or trivial symbols and ornamentation. So it should be direct to the point. It should be clear, should be easily read and understood. So this one is an example of a line graph, and I know that ever since elementary, you have already encountered this type of graph. It's useful for showing trends over a period of time. So the given table is an example, or it is the table for the unemployment rate in the Philippines from 2000 to 2030. Second one is the bar graph. So it consists of series of rectangular bars where the length of the bar represents the magnitude to be demonstrated. So bar graphs, it can be horizontal, it can also be vertical. So this one is the distribution of patients by blood type. So if we take a look here, so for blood type AB, so there are 5 patients. For blood type A, there are 6. For blood type O and B, there are 7 patients. Third one is a pie graph. So it's a circle divided into sectors in such a way that the area of each sector is proportional to the size of the quantity represented by that sector. So this graph is the distribution of faculty by department. So based on the table, there are certain legends here on the right side. This one, that's the legend. So signs. So this one and this one, that represents the number of science teacher or faculty, and this one that represents the language teachers, this one for social sciences, and that for math. Next, we have the pictogram. So pictures or symbols are used to represent certain quantity or volume. So these are the preferred canteen of a sample of 50 high school students. So for every smiley face, the legend is it represents 5 students. So for canteen X, there are 1, 2, 3, 4, 5 smiley faces, meaning 25 students prefers canteen X. For canteen Y, there are 2 smiley faces. That means 10 students prefer canteen Y. And for canteen Z, since there are 3 smiley faces, that means that there are 15 students who would prefer canteen Z. So these are other types of graphs in relation to the frequency distribution table earlier. So once you're able to construct the FDT, you can represent or present also the information in tabular or in graphical manner, I mean. So no need to answer the activity. That's it for this discussion. If you have any questions, clarifications, feel free to comment your questions on the comment section below, or you can also ask in our group chat for me to be able to accommodate and answer your questions. That's it for now. Thank you guys. You take care always. Bye-bye for now.